You're welcome back to our class. We continue with our study, writing circuits in Noir. So today we'll be looking at a different topic. We'll be looking at a key value mapping in Noir. So first of all, we will begin by understanding what key value mapping is. After that, we will get to know how to store and retrieve data efficiently in Noir. Then we look at a few examples, hands-on, so that we create our circuits that will help us to store and retrieve data in Noir. Then we will end by looking at practical use cases of key value mapping in Noir. So that is what I intend to cover in the course of this class. Now, just straight to the definition of key value mapping. This is a technique that is used to associate specific keys with their corresponding values. You will get to know what keys are. So in this case, keys would act as unique identifier, and their values will be the data associated with those keys. Maybe when we look at examples, we'll get to know what these are. But as I've said, a key is just a unique identifier. And then what we call value will be their associated data. So we have key value mapping. So that is where every key is mapped to its value. And by value, we've said associated data. Now, we will get to look at examples later and understand what this means. But we're just saying if we have a key, some key, an identifier, something identifying some value. So we say, for instance, you can give it some value that it would be identifying. Let me say 2 that identify orange, 3 will identify yellow, 7 will be identifying, let me say, red. So 7 will be mapped to red, 2 will be mapped to what it's identifying, and so on and so on. So that is what I mean by that. But when you look at examples, we will get to understand that every key will be mapped to its value. Every key will be mapped to its value, and that is what we mean by this. Now, so the importance of this is they help in efficient lookups. That is to quickly retrieve data using keys. So where you have large data and you wanted to retrieve some specific data, if you did your mapping correctly, then you would easily identify your data. The other thing that it's why we use it is to ensure that your data is organized. And then lastly, for practical applications, is used for word counts. So again, we'll be looking at this, how word count will come in, configuration, storage, and lookup tables. We'll be looking at all this in the course of this lesson. So this is just a diagram of the definition of every key. Like for instance, let me say this is a key, and this is the value of the key. And so this key apple is mapped to its value. This key banana is mapped to its value. So if you wanted to identify, to get the value 5 very fast, you'd just search for banana, and then banana gives you its value. And then if you wanted to get 2, and that is the value you are looking for, you just search for Apple, then Apple gives you its value very fast. So you can see by this diagram, every key has been mapped to its value. So Apple, which is the key, so the keys, and this side, every key is its value. Good. So each key maps to a specific value. So in Noir, we simulate key value maps using fixed size parallel arrays. Parallel arrays, just like the one we are seeing here, but then we'll be doing it in terms of writing the code. So just again, continuation of that definition. We're saying let, like for instance, if I was to write, I would say let, these are the keys, apple and banana are the keys. And look at this, there's some space here. Now it depends with the length of the string. So if I'm writing it now, I'll define the length of the string. So the length of the string, if the length is 8, and like the example I've used the length of 8, so that I want my string for the key. I want the string for the key to be 8. So for instance, you can see this apple is 1, 2, 3, 4, 5 letters. That means I will give it some spacing, 3 spacing to so if you type the length 8 and you give it less than 8, it will not compile. Now you can see this one 1, 2, 3, 4, 5, 6. So I'll just add it 2. That is why you can see this space is smaller than that. Now, if you have a key that has already 8 letters, you don't need to leave some space. You don't need to leave some space. So the space you are leaving it equivalent to the letters that are missing to make it the length of the string. Now, so if I was to write okay, so I can see Nelly asks why do we need the space and the number. So the space is just if you are writing your string and you've defined your string to be of length 8. So length 8, it means your key must be of length 8. That means it should be 8 characters. It should be 8 characters. So in this case, if there are 5 characters, you give some space for one character, space for another character. So it's just when you press, is it this tab, the tab, the one for spacing, just press once, twice, thrice. That is for 3 letters, giving space for 3 letters. And this one is 6 letters. And you've defined your string to be of 8 letters. That means you'll space twice, give it space for those 2 other remaining letters. But if you are supposing your space, supposing your key was banana, so that it is full, like this one is 1, 2, 3, 4, 5, 6, 7, 8 is full. So this one you don't need to space, you just close and open there. You don't need to space it because it equals the length of the string as you defined. So when we begin writing the code, you will now see how we define the length of that string. And so it means that whatever you are taking as the key must be of that length. Now, these are the values. These are the values. Remember, we are saying we are talking of key value, so that every key is mapped to its value. So the first is mapped to that. Then its values. That is about the diagram I had drawn there. just to explain the diagram. This is just a continuation of that explanation, and the explanation of the string is here. So you've defined your string to be of 8 characters. So your string should be of 8 characters. You even have string of 16 characters. It depends on what you want. What you want the length of your key to be. So for me, I've defined the length to be 8. So that means every key I put should be of 8, length 8. Now, so therefore, Apple will be mapped to its value. And 3 spaces, 3 for the 3 missing letters. And this one, the other 2 missing letters, I would space that. Now, so when you compile and run, it's supposed to give you the keys, give you the values. So if you're asking for the key and the value, it will tell you. And then you ask, okay, you ask for this key. So it's supposed to come in this format. Then you ask for the value of this key. It's supposed to give you equals to 2. It's supposed to tell you the value of that is equals to 2. And then if you ask for the value of banana, it's supposed to give you the value to be 5 if you had indicated that that is the value of that key. Now, so how do we create a mapping? How do we create a mapping? In other words, how do we map a key to its value in Noir? So that is what I'm beginning. So you begin by let. Of course, you'll begin by some function. You begin by some function above, but I've not begun by that. I've just come to what is important. We know that we shall begin by function and then close by something else. But now I would say let keys. So I define my keys here. I define my keys. Of course, the function will be giving us the length of the string. The length of the string. So in this case, my function is giving me the length of 8, as I had already said, string 8, string of length 8. Now, my key is Apple. So I just space thrice to leave some space for 3 letters because it's not equal to 8 characters. It doesn't have 8 characters. And then banana, it has 6 characters, so it's missing 2. So again, I leave some 2 spaces. So this is fixed length strings. And then let values. So I give the value of apple and then the value of the banana. So this way I would have mapped. Every time I ask for the value of apple, I will get it to be 2. Every time I ask for the value of banana, it will give me 5. So this one has been mapped. Now you can increase the keys and you can also increase the values depending on how many keys you want. So every key, give it a value. So this is just an explanation, but the explanation of what I've given. Now you may want to add values. So that is what I've said. You may want to add more keys, then add more values. Every key should have a value so that it's mapped to that given value. This is just an explanation. I've said if you explain now, this one have now included the function. I've included this is now a complete is a complete example where I'm mapping every key to its value. I began by function, and you remember because you are doing zero knowledge, you require some values to be public, others to be private, so that those which are public are known to both the prove and the verify. In this case, I've made all of them to be public, but you can change this and make it private if you want, but let this one be public. Because every time the result is supposed to be known by the verifier, so that the verifier can prove what you can be, go through the steps you went through and see whether your proof is okay. Because it's you proving to the verifier that you know some value. So you want to prove, for instance, you know, some keys that will be mapped to these values and so on. So the keys would be, the keys would then be private. You may want to make it private so that the verifier does not get to know what they are. But now every time you run and there is an outcome, he should be able to see the outcome. So the outcome normally in zero knowledge, it's always, most cases supposed to be public so that he's able to see it. But your inputs are supposed to be private. Your inputs are supposed to be private so that they are not known to the verifier. Only the prover knows. Now, so I've said, therefore, we can change this to be private later if you want. And we make this one be public for the reasons we've explained. Now, we've defined our string to be 8 character at this point. So you can change this to any other. So if that is the length of the string, your keys must be of that length. So let our keys be these 2. So the first key has 5 letters. You just make it 8 by spacing 3 other steps to make it 8. And then there's a comma. Then there's another key. And then you make it 8. You can make them as many as you want. But now their values are here. So it's therefore known that this value is corresponding to that key, and this other value corresponds to that key. Now, so if you want to now find out what is the value of Apple, for instance. So I'm now writing a let the result get value, let result get value, and then key. So the name of the key, and then value, and then the key. So that is how it's supposed to come. Supposed to now, it will come in such a way that I have the key and then its value. So I'm just asking for the key, the Apple, for instance. I'm asking for Apple, and then it's supposed to, the result for Apple is supposed to come in this case, in this format, so that it's telling me Apple, its value will be this. So, and then I get the result. I get the result. So this is a complete, it's a complete example. So at this point, now this one is just calling for the other is calling for the above function, so that now it gives me the result. It's calling on the above function. So you can see, we say mute. So the result will begin by 0, and then we'll be incrementing for I in the range of 0 to 2. If the key for I. Now, I did this because at some, when I was trying to, you see this function will have entered here. But if I end at that point, every time you run it, it gives you the result. But then it tells you whatever is the result you're asking for is a constant. So, okay, it gives you the answer, but there's a warning that what you asked is a constant. So I wanted to omit that error, that warning, not an error, but it was a warning every time. So because of that, I now make it to be a variable so that it will be changing. it will be changing so that it's no longer constant. When you make it a constant, you'll be getting some warning every time you run it. It executes, it runs, compiles correctly, but now there's a warning that you asked for constant every time. So I wanted to avoid that by this last function. So this last function was just to avoid that warning. Now, so let me just now show you the practical code so that we can explain much from the code. I don't know if you can see the code. Huh? Can you see it?
Yes, you can. Yeah.
You can even see what I'm typing. Yeah?
Yes.
Okay. Now, so the main core, the first example I want us to look at, its main is here. So that is what I've been explaining. And that is why I said I made this string to be public, and then the outcome is also public, a U8. Then all these are explained. I'm just mapping this apple to its value and this banana to its value. And then, I share the code. So let me share the code in the chat. Now, maybe just if you've forgotten how we do it, you just open your VS Code, not the VS. You can open your WSL. Open WSL. Let me just give you the steps. So after opening WSL, you can CD to where you normally store your programs. Let me say maybe you store them in Rust programs as I do. So you CD Rust programs, then press enter. Then you will also, or you can even CD the whole thing, the one I'm typing. After CD Rust programs, you want to open a project. So what you then do, after pressing enter, you would say make directory, and then the name of the directory, you can give it, let me say a lesson. You want to call it lesson. You want to put lesson 1. Okay, so you can see I've said CD, Rust programs, and then that is where you normally store your project. So that is where you are CDing to. And say make directory, lesson 1. Then after that, you can now CD lesson 1. My lesson 1 was capital here. Let me remember to put that, lesson 1, then enter. Now, after that, you can say Nago initialize so that your project has Nago. And then your project also has the SRC and the main.n. So when you say Nago initialize, you press enter. Then after press enter, you can now come back and say code, then space dot, then enter. So you will then see your program open. Now, so maybe I can now use yours to explain I can use you as who has opened? Nelly, yours is red. Is that okay? Okay, you can now share. Nelly,
Yeah.
you can now share yours.
Yeah. Let me share mine.
Okay.
Just a minute.
It's okay.
Just a minute. I might have to drop off, then come back into jumps. Just a minute.
Yes, yes.
Can you see my screen? Hey, are you
Yes,
guys seeing my
I
screen?
can see it. Okay. How far are you? Try to move it. Try to increase it a bit.
Okay. Let me.
Okay. Now, so what was the outcome?
The outcome is this one. The circuit output is field 2.
Okay. You are now go proton.
Here is what my
Okay.
silver terminal
Okay,
has.
good. That's okay. How did you arrive at that?
I forked a repository on GitHub.
Okay.
This is the code.
Okay. So now what you do? Okay, I want to show you. How to arrive at that. Yeah?
Okay.
So just delete the Nago Tomil.
Okay.
Yeah, so that I show you, not the nagotomil, the provatomil.
The prover.html.
Yes, yes. So that I show you how I got to that.
I deleted it. Should I delete the target folder?
The what?
The target folder.
No, just leave it. That one has no problem.
Okay.
You can see it's faint. Is that okay? It's faint.
Yes, yes. Okay.
Yeah, it's faint. It has no. Now, so just type in the that what, how do you call it, in the terminal? Type there nago check. Check. Then it has brought the provatomil. Is that okay? But without what is inside? Yeah, it has given
There's
you
nothing.
Yes, but it has told you that the provatomil is supposed to have key equals to something.
Yeah,
Is that okay? Yes. So that's something. Now we can type inside the key, and you can type the apple inside in those. Okay, and then space 3 times, because we want our key to be of length 8. You have done 3 times. Is that okay? Good. Now you can run your nago check, nago execute, and I think that one is now compiled. Now just run that. Nago execute.
Here's the output.
And the result is the field is 2. So that means Apple has been mapped to 2. Now you can also change the key to banana.
Okay. Let me change to banana.
Yes, you can change that to banana. Then space twice. Times. Yes. Then now go execute. Let me see.
Yes, we have the output.
It says banana is mapped to 5.
5. Yeah.
Yes, banana is mapped to 5. Now you can also try the key to be something else that is not in our code, just anything else. Because we only had apple and banana, so you can put anything else. And orange has 6, so you add it twice.
Let me run nago execute.
Yes.
So here's the output.
What does it say?
Says that the circuit output is 0, field 0.
Yeah, so that means that element is not there. So it's not failing, it's running, and it's telling you that the key that you've chosen does not have a value mapped to it. So it's not mapped to any value. So that is what it means. Now let's go back to the main.nr. And we can add there, we can add orange after banana, underlate the keys. Okay, just put a comma, and then
so I'll put a comma and then tab.
I can see the word orange there.
Yeah.
How many tabs have you put? 2.
Yes. Yeah, just 2
How
spaces.
many? Okay, give it a value. You've given it 10, eh?
Yeah.
Okay, now go and run. Now go execute. Let's see what we get. What does it say? Oh, string is 3. We said it. Let's go back. Let's.
Okay. Yeah. Then the key values.
Where we have U8, where you
Yeah.
have U8, the function at the bottom,
The
we had
function.
defined 2 values.
Where is it? Yeah.
Yeah, there we can change that 2 to 3.
I put 3 here.
Yes.
Is that okay?
And then just in the function above it, there is a 2.
Yeah.
The function above, there's a function just above the 3 you've written. Function get value. Function get value, keys, string.
So what should I add here?
No, not there. Are you seeing where there's a result?
Yeah,
Where there is a result?
result.
Yes, there's then a function after that. No.
This function?
Yes. There, where you are pointing.
Yeah. What should I add? I should 2, so I put 3 over here.
Make it 3. Yes, make it 3. That is line 12, yes. And then again,
and is this okay?
the same. It's okay, there's no problem. Then the other one.
3.
Okay, try to run that and see what happens.
Yeah, it has worked.
So it says that key has been mapped to 10.
Yeah.
Is that okay?
Thank you.
Yes.
Yeah.
Now look at there's something I've put there to automate. I put there run query.sh.
This one?
Yes. Good. That one is supposed to automate. It's supposed to give you the proof atomil automatically. Then it's supposed to execute automatically. So you don't need to make the proof atomil. Then you don't need to give it. So when you run it, first of all, for you to run it, you need to execute it to make it executable. I don't know whether you've made it executable. Yes.
I don't remember the command exactly, so I'm not sure if it's.
It's in the README. It's in the README. Just check in the README. There's a README for that example. That example has a README somewhere.
Yes. I saw it.
Yes, it's there. So you copy it, all of it. That is now to make it executable.
Yeah, and then now I can run the run query.
Yes.
So it says that enter the key to query. So maybe I could put
Now you give it,
orange.
right, apple.
Okay, let
You
me
can
give it
put
apple.
orange. Yes. Then
Apple,
you check
and then
the,
we add. So should I
just
put the
no,
space
just
also?
up.
Okay.
No, just say apple and then enter.
Ah, yes. That's what?
Because I've already told it, it already knows the string is supposed to be 8. It's supposed to be
Ah,
of length 8. So when you just give it
uh-huh.
apple, it will top up.
Uh-huh.
Will top up the remaining
The remaining.
spaces.
Uh-huh.
And then when you go to the probatomil, you'll find that it has given you the right probatomil by itself. Just check the probatomil.
Yes, yes. It has actually changed.
Yes. So what it does, it changes what was there. So you can again run it and now give banana. It will change the probatomil by itself and then give you what it's mapped to.
Ah, yes, yes, yes. It's mapped.
So has it mapped banana correctly?
Yes, it has,
It has
but
mapped to
yes,
5.
yes.
What about the probatomil? It has already changed automatically.
Yeah, yeah.
Yeah, so that is that is a that is a script, and that one helps you to automate your process so that you are not repeating same commands every time. It does it for you. Now try and give it something that is not there. Give it something that was not there, and you see what it does. What has it said? No, you see, pineapple is longer than 8. It's longer than 8. Is that okay? The word you gave it is longer than 8. So give it a word that is 8 or less.
Okay, let me maybe just make sure that the
Or make them 8. Just make them 8.
Let me just make it 8. 1, 2, 3, 4, 5, 6, 1, 2, 3, 6, 7, 8. So
Okay.
yeah, maybe
That is 8.
let me just yeah,
Okay.
that's
Enter.
8. I had not run the so I'm gonna give it
Oh, okay. Yeah, you did not run the run dot query.
yeah, so wait, it's smaller, it's smaller. Let me just so 1, 2, 3, 4, 5, 6, 7, 8. So it says 0.
Yeah, it runs and then it is telling you that this
Huh?
key has no value. There's no
Yeah,
value.
yeah.
It's not assigned to any value.
Yes,
It's
yes,
not
yes.
assigned to any value. So it runs. It runs, but it tells you it cannot find a value assigned to it. So that's what
Yeah.
it's saying. Now, so you can always change the string length. In the example above, we've used length of 8. You can make it any other length that you want, and it will still work. So the only thing, if you're doing the probatomil by yourself, manually, you need to know that you will be spacing until you make the exact length. But if it's the exact length like the one you've used, there's no need to space. So the probatomil will give the exact. You can see like the one you have there. You can see the pineapple has not been spaced. There's no spacing. Is that okay? In the
Yeah.
probatomil. So it means it fits the exact length required. Okay, so the other thing I wanted us to do what is that example. Oh, okay, let me share my screen first and then you come back. So that is about writing that. So already we've done this, we've tested our understanding. We've seen that we can query banana, and then it will give us an answer, what is mapped to banana. So banana in this case is our key, and its value is 5. So when we query it, it gives us the right value. So this one we've already done. About the prove-at-all, we've already explained that when you write banana and you are using string of length uh, to make it complete, then you can use nago execute, and it will give you the value of the key. Now, so I've also talked about automating this process, and we talked about this equation. Now, so you can see it, whenever there are less than 8 values, it was to top up for you to make it 8 values. So what this one did, once you run it, it will ask you to enter the key. And then once you enter the key, it will make it, will put the remaining spaces so that it has 8 values as we wanted. So it pads, what the term is that it pads with the empty space. It pads with the empty space so that you have 8 values. And then it gives you the prove-at-all automatically. So if there was an prove-at-all, it replaces it with the correct one. Then it does nago execute for you and it gives you the result. So that is what it does. You can always adopt it and make it do more other functions for you. Now, so before we look at other examples, I wanted us to look at why do we need this key value mapping? Why do we need it? And I've given reasons for efficiency, organization, and versatility. This one, again, I explained it. I explained them from the beginning. Now, the other use is counting word occurrences in data sets. So we may want to count, we want to know how many words are there, how many words are there. So you have a very big sentence, for instance, a sentence with so many words, and you want to know how many words are there. So this will count for you the words and tell you how many words are there. You can also use it for storing user preferences or settings, implementing caching mechanisms for faster data access. Now, so we look at all this, those examples I've designed all of them to answer these use cases. Now, this part we've already done it. We've already done it in the previous example where we are retrieving values. So for instance, we want to retrieve the value assigned to apple. We want to retrieve the value assigned to banana. So that is what we've been doing in our previous example, retrieving values. So you remember you have these values and there are so many and you want to retrieve them. So you just write the key and then you get the value assigned to the key and so on. So that is what we've been doing when we talk about retrieving values. Now, so we can also modify values. Look at this example that I'm just looking at here. Now, this is an index. I talked about indices in our last lesson last week. Not last week, on Tuesday, the lesson I just taught the other time. I talked about indices, and indices are used for identifying values, the position of values. The first index is index 0. So if we have values 1, 2, 3, 4, 5, and we want to identify these values, their positions, so you would say value in the position index 0. This value is supposed to be 1. That is a value in that position index 0. So value in position index 1, this value is 2. So we begin by index 0, index 1, index 2, going forward to identify values, to identify positions. Now, so for instance, this is index 0, and this is index 1. But when I talk of modifying values, we want to modify values, without mute, these values are permanently this way. They're permanently this way. That means you cannot mutate them. You cannot mutate them. When you remove the word mute, those values become permanent. So it means, for instance, if this was to be mapped to Apple, you cannot change it to any other value. So Apple will always be mapped to this 2. Banana will always be mapped to this 5. But if I return the word mute, that means I can change these values. So if banana was initially assigned 10, I can assign it another value. I can even assign it 100. I can assign it another value. So you can see in this case, I've said value at index 0, I am now assigning it 10. Although it was 2, I'm now assigning it 10. So, and again, the program would accept. So that when this time now, when I ask for the value for Apple, what will be printed for me will be 10, because I changed it. So modifying means just changing those values. You want to change. So this is, you had assigned these values earlier. You had assigned these values earlier, and at some point, you feel that you want to change those values. So that means your equation, should have mutation, you should have mute, so that at any point you feel you want to change the values, you can always change. So in this case, I've just changed this value for this position, and I've now called it 10. So that is how we change those values. So I think, okay, and then we can combine these two, and then we can also remove values. You can remove values. So if you had already assigned values to be 2 and 5, you don't remove by erasing. Don't remove by erasing. You just assign. You want to change this. You want to remove this value 5. You want to remove it. So you just assign it. It's a value in index 1. Because this is index 0 and then index 1. Just say the value at index 1, I want it to be removed. So if it's removed, it becomes 0. Just like we saw the other examples, whenever we asked for keys which were not there, we were given values to be 0. So, and I said at that point that 0 meant that the key was not assigned any value. The key was not assigned any value. So when it's not assigned any value, what then comes out is 0. That is what comes out to mean that it has not. So if I had said mute and the values were previously 2 and 5, 2 for apple and 5 for banana, and then I come here and now change the value for banana, index 1, change it to 0. It means I've removed it. So if I now go and ask, I do the same thing we've been doing, and then ask for the value of banana, what I want to do, or what I will come out will be 0, to mean that it was removed. It was removed, so its value is no longer there. So this is how you remove values. And we've seen how to add values by mute. So let's just, again, you can share so that, again, we look at that example 2.
Okay, or if, okay, yeah, let me share. There, head. So we're looking
Oh.
up to.
You can refresh the terminal. That's example 2, the one you are pointing at.
Yeah. Let me see the key value pairs. Value map, and then be into second example. So yeah. There, the second example.
Okay.
Okay, so I'm going to remove this approver.uml.
What is that? Oh, okay. There's no problem. What about the main? Let's look at the main first of all.
Just
main.nr.
Example main.nr. Yeah, there we go.
Okay. Now, so at the first point they have written, they are modifying values. Update the existing. Is that okay? So the function again is just still using the same function, the same length, length 8, and the keys. So we have apple and banana. Okay, and their values are 2 and 5. Now I'm reading line 6. Line 6 there, what I'm seeing that the value for the first index, 0. Line 6, line 6. Line 6, okay, you're there, is that okay? Index 0, we are changing the value 2 to 10. Is that okay? So that means whenever we ask for the value of the apple, this time we have updated it to 10. So that is what will come out, not 2. Okay. Then the okay, so the whole thing is okay. Now let's do it. You had deleted the prover.
So I'm gonna do nago check.
And say nago check.
Yeah, so the prover has been generated, and maybe now I could put apple to see what was there, and then 3 spaces, 1, 2, 3. And I'm gonna save that, and I'm gonna come here and do nago execute. Yeah, so this is the output. Yes. Yeah, it actually outputs 10 instead of 2. So it has been updated or modified.
Okay, let's just go back to main.nr again and look at it and erase the word mute. Erase the word mute.
Erase the word mute here.
Yes.
Yeah.
So. Okay. And then again, do nago execute and see.
Yeah, it says that the variable. Wait. It says that the variable values must be mutable.
Must be mutable. To be assigned to 10. For you to assign the first value to be to 10, it must be mutable. Otherwise, you cannot assign it to 10. It's already 2. Is that okay?
Yeah, yeah.
It has been assigned 2. So for you to assign it 10, you must make it mutable. So let's just do it, make it mutable. Make
okay,
it
so
mutable.
let's
Just
let's
yes.
let's
That's just the word mute. Okay, that is now okay. Now, so
yeah.
let's assign the second value to 100.
Okay, so that means I'll change this to
1.
I'll take 1 and then I'll change this to 100.
Yes. Okay, now let's again do for the banana, you change the probatomil.
Yeah, so let me change the probability here now. That's 1, 2, 1, 2.
Okay. Now go execute.
Yes, it has output 100.
Yes, outputs 100. Now, so if you want to remove, let's just go back there and remove banana, the value for banana. So if you want to remove the value of banana, you make that value to 0, not 100.
Yeah, yeah. So 0.
So now,
yeah, it outputs 0.
Yeah, so it means the value for banana is not there.
Yeah.
That is what it means. That is the same thing. If let's change the let's change the probatomil to something else.
Okay. Orange. Let's do as we had done earlier. I'm using Vim, so at some point it gets fun, especially with the little values. I think I can. For Vim, it's kind of hard to understand in the first place, but then when I understand it, it's gonna be okay. So let's put orange. And then orange has 1, 2, 3, 4, 5, 6. So 1, 2. Okay. And then let me try now go execute. So it says that, yeah, 0.
So it means orange is not there. So when it gives you banana 0, whether with banana there, but it means banana has been removed.
Yeah.
Whenever it gives you 0, it means that thing has been removed. So that is what it means.
Yeah.
Yes. When it gives.
Yeah, yeah.
When it gives you 0. Okay. So the other thing. Okay. I have the run. No, just share. We have that run .sh, and I wanted you also to use it. So again, you'll begin by making it executable. No, but since you had run that, I think it will still be working. Okay, so it says enter key to query, and it says maximum 8 characters. Try that, try what you've just done, press enter without, just press, you have done Apple, then just press enter without adding the spaces. Let's see what happens. That's given you, good, it has given you that it was mapped to 2, so the probatomil has automatically been updated. And then you can also try banana, which we had changed to 0. And again, it does. Okay. So maybe now we can look at something else. You can unshare now. Now, so we want to count how many words are in a given sentence. So that is what we want to do. So this is called, I've called it counting occurrences example. So I want to see how many words do we have in that sentence. So the code is this. We are still mapping elements to their values. And so we are using that now to tell us how many words are there for this value and so on. So again, this code I had written it, but because it was, whenever you do it with a constant, it tells you that this thing is a constant. So this that warning, and then I had to rewrite it so that we have this format. You're seeing what I'm sharing, is that okay? Or am I not sharing? I think I'm sharing.
Yes, you're sharing. Yeah, you are.
Yes. So for word in words, for word in words. So we have several words. Now, if word is apple, okay, with this space to make it 8, let it be the first word. This is index. Index gives you the position. That is a position. That is the first word. Increment by 1. So you've counted it. Else, if word is banana and is in position 1, so make it be in position 1, and then again increment it. So what this one means is this. I want to count these words and write them in this format. The first word, how many are they? The first word is supposed to be apple. So the thing is, how many are they? So their number is put there. Then the second word is banana. That is what I'm saying. This is position 1. So then after counting, when you see a number like 3, that one stands for the word which was in position 1. And the word which was in position 1 is apple. Then if you see something like 5, that stands for the number. So the word in position 2 is banana. So if you see 5, it's telling you that we have 5 bananas, 5 words, banana words. And then the word in the third position, I call it cherry. If you see 10 in the third position, so those are the number, the word cherry, how many are they that you're seeing? How many are they? So they'll be 10. So that is what this means. So that's what I've written here. I've said if the word apple in the first position, then count it. Every time you count it, you increment by 1. Every time you get it, you increment again by 1. So you found it first time, that became 1. But before that, we had initialized their numbers to 0, 0, 0, 0. That is what we did here. We initialized the counts. And then we made these counts to be mutable, so that they be changing every time we meet that word, it changes. So they're mutable. So we have 0 apple, we have 0 banana, we have 0 cherry. And when you meet apple, this number changes to 1. When you meet banana, this number changes to 1. When you meet cherry, this number changes to 1. When you meet Apple another time, it changes to 2, and so on. So that is what is happening here. That is what this code is doing to count. So I think that should be in our example 3. Let's just share example 3. I don't know whether it's example 3 or example 4. I think example 3, we might have already talked about it when we were talking about example 2. We combined the 2. What is an example 3? Example 3 we are removing. Is it? Yes, we are removing.
Yes, what is an?
Yes, example 3, that one is removing words. You can see value in position 2 has been made 0. So we are removing banana. Yes, removing banana.
Yeah.
So that is what. So that one we've already done it when we were looking at example 2. So let's look at example
4.
Yes, example 4. Okay, yeah, it's that one. This is the one that is counting. This is the one that is counting words. And is saying that if the word is apple, in position 1, increment by 1. Now look what the prover told me. I've already put it. Prover told me, so that one you don't delete. Let's just see what it is. I've put there a number of words, and I just wanted to count. I just wanted to count and tell me how many apple are there, how many banana are there. You can add something, you can add even banana. You can add banana, but remember the spacing. Put a comma first. Just copy 1 banana and then paste with the space. Oh, okay.
And with the
space, banana was 2.
1,
the
2.
Spacing for banana was,
Yeah.
And then add another one if you want. Because we just wanted to count. We just wanted to tell us how many bananas are there.
Okay, so maybe I could add another cherry.
Okay.
Cherry has 1, 2, 3, 4, 5, 6. And then I'll add 2. 1, 2. Yeah.
Okay. Now execute. Just execute.
Okay, let me see.
That is fourth. That is fourth example. Okay.
Example, and then I will execute. Yes. It says that it has an error, but here it says that the value for parameter words does not match the specified type.
Where is that? I'm not
sure.
seeing.
Here in the terminal.
Yeah. I think the spacing for banana, let's just check. Just copy 1 banana that I have and replace.
Okay.
Did you space twice? Okay, just copy that. Copy the whole thing.
Just a minute. So let me paste that. So yes, I've pasted. Let me try to save the file. Yeah, let's try and execute again.
Are you pasting the right one? Yours was at the. Yours was at the far end.
Okay.
Yes.
Yes. Let me try to save. Then,
execute.
Yeah. Okay, so it says it has an expected Should this is this supposed to be here? This so
yes, supposed to be closed.
let me see cherry. 1, 2. 1, 2, 3.
Yeah, just check and see whether cherry is correctly. Is cherry correctly?
Oh. Yes, it should be says invalid.
Invalid what?
Let me show you the error. Here's the error here.
Fail to deserialize inputs. Input file is badly formed.
Yeah. Could not
Okay,
pass
just delete the
HTML
whole thing.
pass.
Just delete
I
the
delete
whole
the
thing.
whole thing.
Just
Okay.
delete the whole thing. Let's just make it. Just delete the whole prover Tommy. Just delete. Yes,
I've
just
deleted
delete it.
it.
And
Send me the right one.
yeah. Now we will just make it.
Okay.
Just delete. Yes.
I delete the file or the contents of the prover.
Just the file, even the word prover Tommy. Let's just do Nago check and see what we get.
Okay, let me see. Nago check. Yeah, so the prover has come.
Okay. Just now put there the words.
And then 1, 2, 3, 4, 5. So I'm gonna do space 3 times. 1, 2, 3. And then I'll put banana. 1, 2. Oh, just a minute. Banana 1, 2, 2. And then here maybe I could put cherry. 1, 2, 3, 4, 5, 6, 7, 8. Maybe I could put apple again. And 1, 2. Put maybe banana. 2. Maybe let me add banana again.
Okay.
Yes?
Yeah, it's okay. Okay, now try and execute.
So, wait, it says that the value passed for parameter words 3 does not match the specified type. It's there.
The words,
Oh, but
the value passed.
it's the apple that I didn't add. Okay. Apple 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 5, 6, 7, 8. Yes, I think that was the problem.
Okay, try again. Let's see.
Yeah, it has passed. Has executed. Okay, so this is the output.
Now it has told you that the first word, there were 2. The second word, which is banana, are 3.
Banana 3, and the cherry
and then
is
cherry is 1. That's what it's saying.
Yeah.
From output.
Yes.
So it has counted for you those words. So you can make them as many as you can, but it will always count those words and give you the exact number.
Okay.
Okay, let's go to the last example. Just share the last example.
Here's the fifth example. Yeah.
Now, this one is just showing you how we can use it in real life to do that. Of course, what we've just done, the first one, a word count is one of the things we can use it in real life. And so just do now execute and let's see what happens here.
Okay, let me CD into example 5. So CD, tab, let me see, now go execute. Okay, so it has a warning, but then it has said that the circuit has been.
Let's look at the warning. The return variable contains a constant value. So this is what I was.
Okay.
Let's go to the proof atomic. Change the theme to language. Change it to language. Let's see what happens.
So, like that?
Language, okay, language has how many?
Language
has how many letters?
It has 1, 2, 3, 4, 5, 6, 7, 8. So I'm gonna remove the space.
Yes. Okay, run it and let's see whether the warning is there.
Okay. The warning is not there.
The warning is not there. So this warning, it goes when you interchange the keys. When you interchange the keys, now return the key which was there, return a theme. And let's see whether the warning will be there. Or before you remove before you replace, run it again. Let's do now execute while language is still there. Just run it again. Okay, run it another time.
Okay.
So there's no warning, huh?
Yeah, there's no warning.
Okay, now replace the key and let it be theme. Just above. Above. This one has a hash, it means it's not functional. The one above, where the language is.
There?
No, the key, the one that is above, line 1.
Okay. All right. So let me close it. So I'm gonna change this to dim.
No. Key, it's just key, but now the language, you change the word language to
theme.
Yes.
Okay, theme.
A space. Theme has 5. Theme has 5. Add
1, 2, 3, 4, 5. So 1, 2, 3.
Okay, let's again do it.
Okay, let's execute. Yes, it has said that the circuit has been definitely solved.
Yeah, so and again the point is it has no warning. So what I was saying, every time you interchange, use a key. When you use a key several times, it takes it to be a constant because it has seen it. It has seen it before. So when you use it several times, it's assumed to be a constant. So if when you change, not a permanent warning. But let's go to the theme. Let's go to the main.NR and see what it's about. Now, so when you look at that, just move down, okay, just above here, where we have line 3 and line 4 and 5. That's where we've defined the keys. And we've said the key theme should be mapped to dark. Language is mapped to EN. So this, you see, like the last example we're just using. So you can, it's not a master, you must use values, you can use something different.
Okay.
And that's why I'm saying this time I'm using theme mapped to dark, value is mapped to AN, so you can map it to anything else. But when you run, you can see like in the last running, now you execute, it gave you dark. When the theme was the key.
Yes.
Now, so that is what happens. So when you run language, then it will give you EN. Like I can see the second last run.
Yeah.
Yes, it gave you EN.
Yeah,
so
yeah.
that is what I wanted us to cover today. Now, so I think our next lesson is on Wednesday, and we look at more other things in Noir, so that we learn so many things, how to write Noir circuits for zero knowledge proof. Unless somebody has a question. Any question? Okay, if there's no question, I think we can end at that. And then we meet on Tuesday. Thank you.